I've been using AI now for a couple weeks on a pet project of mine, and I have to say that I feel like it made me a worse programmer for a variety of reasons. And I think it's something worth talking about because these AI tools like ChatGPT, Claude, Amazon Q, and others are getting increasingly popular, and we really need to be careful when using them. So let me explain to you what my learning and development cycle looked like without AI before jumping into what it looked like with AI and talk about some of the problems that I identified. So I was recently working on a project where I needed to publish a notification to a Discord chat. And typically how I do this when I don't have any AI tools available to me is I go straight to the documentation, right? I go and look at the docs and I say like, what's there? What's available, right? So this usually takes some time. I check this out. I go and look at all the different APIs, the different integration types, et cetera, et cetera. So I spend some time reading these docs and trying to understand like, how does this new thing work, right? How does Discord work? What are the APIs that are available to me? Which ones are ones that I could potentially use? What are the inputs? What are the outputs, et cetera, et cetera. I then take this information, I kind of absorb it, and then I kind of try things out. Maybe sometimes it works, maybe sometimes it doesn't. Eventually I'll probably come back and, iterate on this. I'll read the docs again, make some improvements, come back to my editor, make all the changes, and eventually I get this working. The benefit of this is that at the end of the day, I feel like I actually learned something, right? I feel like I now understand how Discord APIs work in this specific case. And if I had a second project where I need to reuse these different APIs, I feel like I can easily do that. I have a good understanding of how the system works. So this is a good thing. These are transferable skills that I can apply to any other project going forward. So far, so good. So now let's look at what my cycle looked like when I was using AI for this particular project. So same thing again, you have happy little me over here. This time, as opposed to going to the documentation, I was just interacting directly with my code editor, right? I was saying, how do I integrate directly with a Discord API to publish a notification? And what it spits out is an answer, but there's a variety of different ways to do this. And maybe it'll give me one method, it'll give me two methods, it'll give me three methods, and it may actually spit out the corresponding code for each of these methods so that I can actually have it working very, very quickly. Now, I will say that I was able to get it working pretty fast, but I didn't understand why. I didn't understand why it was working. And at the end of the day, sure, I was able to accomplish the task. I was able to publish something to Discord, but I didn't learn anything. If someone asked me in a code review, why are you using this API and not this other one? I wouldn't really have a good answer. And this is where my big problem is with AI tools. I feel like more and more people, especially newer developers or people that are under a time crunch, are relying on AI tools and not necessarily understanding what they are doing. They're more focused on the output. They're more focused on getting the task done, which isn't necessarily a good thing. You're just able to churn out tasks really, really quickly. But at the end of the day, did you actually learn anything? Can you actually talk to anyone else about why you made a certain decision? Do you understand the limitations of the approach that you decided and what the other approaches are? For newer developers, this is honestly a huge trap that you can fall into. And I read more and more about this on Reddit and on different social media, on Twitter and on all these different apps of people just having CRs put in front of them by these developers. And it's like, what the hell is this? What is this garbage? And why are you doing it this way? We already have a utility method that does it this way. So I feel like this is becoming more and more of a problem. And honestly, the fact that I was able to get it done pretty quickly with AI, sure, that's a good thing, but I feel like I didn't really learn anything. And what I ended up doing at the end of the day, I ended up going back to my old method. I ended up going back and reading all the documentation, realizing that the approach that AI gave me was actually not the approach that I wanted to use. And I just kind of re-implemented it after reading the docs and understanding what the correct method was for my use case. So that's my issue with AI for programmers and how I feel that it made me a worse programmer. If you feel like this is happening to you or maybe people around you, I would love to hear your story down in the comments.
When we talk about AI in healthcare, I think we need to understand it as a foundational change in the toolkit we have available. In the same way, and I mean this profoundly, that algebra changed our understanding of the world and of math.
In our field, the major changes are happening in diagnostic testing. How we can now interpret them more effectively and without as much expertise needed. We are like seeing the old patterns of care change into new ways of doing care.
The topic of how is AI going to be used is so interesting because these new machine learning, sophisticated models, they aren't the end of the question, it's the beginning of the question.
AI is the future of healthcare, or so we've been told. But what does it mean? Is it coming for your job? Is it saving your life? What risks does it pose? And how does it have the potential to affect you?
Artificial intelligence has in some form been around for decades, but most people are just finding out about it because of things like ChatGPT, which have come into the mainstream. In healthcare, artificial intelligence has been around for years as well. It's helped doctors transcribe notes faster. It's helped with patient experiences with chatbots. But with generative AI, it's really supercharging what healthcare professionals and scientists are able to do by helping predict future health risks, make diagnoses faster and more accurately, and also helping with potential drug discovery for new novel treatments and therapeutics.
The AI boom really hit healthcare in the last 5 years. We've actually been able to transition into having the models or the tools we built to actually work with the data very effectively, and have been able to define new ways to treat diseases, new ways to diagnose diseases, and finally find individualized signatures of how I as a patient or somebody else as a patient would do if they got a certain treatment or therapy.
The Gen AI boom is assisting doctors in more advanced ways, but both clinicians and patients are questioning the risks these new technologies may bring with them.
I think a lot of people are wondering, what's this going to look like when I go to the hospital, when I go to the doctor? How's it going to be used to inform decisions? What about errors, false positive, false negatives? Who's going to be responsible? There's a lot of questions around this that really begs the expertise of people in different areas.
So we have agencies like the U.S. Food and Drug Administration that does oversee certain uses of AI in healthcare. There are also groups like the American Medical Association and the National Academy of Medicine that do put out guidelines and codes of conduct for responsible use of AI. So right now there are experts and there are various groups that are trying to oversee this and make sure that it's used responsibly.
So there's this big tension about how AI will affect our workflows. Clinicians have the ability to interact with patients, understand their preferences. So I still feel they'll have a key role to play in interpreting the outputs that the AI technology gives them.
While the larger AI labs from Google to OpenAI are trying to disrupt the healthcare industry at large, there are smaller and more focused labs within academia dedicated to applying AI to specialities.
Well, we assessed how well the model performed looking at different views.
We're seeing an increasing investment in AI in healthcare. Since 2020, there has been a substantial increase in venture capital funding coming into this space. In 2024, we saw around $11 billion in funding going to various different AI and healthcare startups. Experts say that academics have different priorities than some of these AI startups. Academics can fine-tune large language models, and they may have a different incentive to develop ethics guidelines around their responsible use.
I think our biggest risk with AI is making sure we use it responsibly and consistently. We want people to pursue this creativity to the ends of the earth, but we also need clear processes in place to ensure that before they ever make it in front of a patient, they have been through a series of stage gates and reviews to ensure they are safe, effective, fair, and equitable.
Yale has invested $150 million towards AI development over the next 5 years. One of the ongoing efforts at Yale Medicine is the Cardiovascular Data Science Lab, founded by Dr. Rohan Kera in 2020.
So this is the Cardiovascular Data Science Lab, or the CARDS Lab. It's not a single domain of AI that we work on. We work on diagnostics, on precision care, or defining therapies that work for individuals, work for cardiac imaging, and other ways that we use to enable better care for patients. A good example is electrocardiograms, which are electrical recordings of the heart taken with stickers on the chest, available world over. The ECG GPT, which is a play on ChatGPT, it takes an ECG image and generates a report. That is an example of generative AI. We can generate a full report directly from the electrocardiogram. Originally, this would require a cardiologist to interpret these studies, but our hope is that this can form the basis of very accurate reads that are available world over that eventually clinicians can confirm and use in their care. So we decided to focus on app-based solutions rather than things that integrate in large health systems so that these tools are truly accessible.
Here we have a typical 12-lead ECG. And we know, me as a human reader, I can see these are the leads coming in from the chest. But for me, looking at this, I could never tell you this is a patient with heart failure just based on their ECG. What the AI eyeball is able to do is to kind of isolate these two leads and detect some signal that triggers that, yep, this is someone with left ventricular systolic dysfunction and ejection fraction of less than 40%. And it visualizes it in a way that a human reader wouldn't be able to detect.
While facilities like the Cards Lab are developing these new AI tools at a rapid pace, there are still many steps needed before these technologies can be implemented. To ensure the public well-being, regulators may wish to impose oversight and guardrails before AI becomes the new standard practice of care.
In terms of AI and misdiagnosis, experts say that the cases of and examples of this are pretty limited at this point, because even though an AI might make a mistake or might make a misdiagnosis, there is still a real doctor involved in the diagnosis or prescription of a medication.
So are we really going to become healthier? I think it's not just the $1 million question, it's the $1 million life question. There is benefit to technology, there is benefit to AI systems, but it really requires that all of us, we need to be able to access, we need to be able to use this, we need to be willing to use it, and we need to have that space or energy to do it.
You know, on the wall of my office, I have 4 photographs. It's the transistor, the camera, the telephone, and the source code for the World Wide Web. Because to me, those are the enabling innovations in my lifetime that transform the way we deliver care. Telemedicine, electronic health records, MRI imaging, all of that derives from those foundational innovations. I think AI is in that category.
I want to distinguish automation from being autonomous. Automation is the process of having a fixed set of instruction put in place so that we have repetitive tasks being executed.
Autonomous means that the robot can make decisions without having an operator watching it. So that means it can make decisions that, based on the mission it has, to be useful within the definition that has been put in front of it.
It needs to continuously adapt to changing conditions, and that intelligence is powered through AI.
Electric cars can identify objects. They can calibrate themselves to the lines on the road and make decisions. That's the simplest kind of autonomy that you can have. Then you can increase the level of autonomy to other situations, like what if somebody is crossing the road?
Having AI be part of scientific experiments can create so many new breakthroughs that were not possible before. Here at Caltech, our goal is to design autonomous air ambulances, continuously surveying and looking for accidents as they happen. It has to be able to detect that.
In the future, we will have autonomous catheters that can, say, remove a tumor or repair a heart valve. Connectivity through AI is the next step or frontiers of the prosthetics, as an artificial leg that knows and aware of the whole body.
We can go and explore these new planets. We have done this in Mars. Think of the planets and moons beyond that, and be able to have even more intelligent decision making of what would it take to look for life in these distant worlds. AI has a huge potential to speed up our simulations and ultimately bring autonomy both within this planet and to worlds beyond.
Infrastructure fundamentally is what I call the engine behind the growth of this company. We have been building data centers since 2010. We're talking about serving maybe a half of humanity. Now when we're talking about AI, you need a similar engine behind AI so that AI can achieve the potential that we are sort of dreaming.
AI workloads are growing at a pace of 1,000x every 2 years. I mean, just contemplating what that means for our systems, our silicon, our software stack, we're in the middle of a pivot to the next age of information.
The models themselves are becoming hundreds or thousands of times larger and more complex. And what this is going to require is infrastructure at the exaflop level.
We're reimagining everything we do about our infrastructure for AI. We're creating data centers that are specific for AI. We're creating new hardware, including our own silicon. We're building out new kinds of network architectures. We're reimagining the software stack like PyTorch. Thousands of engineers are innovating on this large-scale infrastructure that's built specifically for AI.
Meta Training and Inference Accelerator. It's Meta's first in-house silicon. It was designed solely for recommendation models in mind, and it is a piece that fits with the rest of the system like software ecosystem for writing applications and deploying ML models. And it's built in-house.
By having it in-house, we are able to optimize every single nanometer of the chip. So we don't have any part of the architecture that is wasted. And that helps to bring down the power.
The fundamental target in designing this MTIA is to provide highest performance in the lowest power. And in the process, we achieved twice the efficiencies compared to today's GPUs.
Another silicon product built by Meta is MSVP, Meta Scalable Video Processor. People spend more and more time producing videos and sharing videos. That means more and more pixels will hit our data centers.
MSVP processes these videos 9 times faster than the traditional software encoders, maintaining the same video quality at par with the software encoders and at half the energy.
MSVP can be the final engine that takes all the generative AI content that people create, eventually needs to be encoded. It can never traverse the internet in its raw format. All these requirements put together necessitated the design and manufacturing of MSVP.
So our new silicon hardware is going to need a new home. We're working on the next generation data center design. The move into sort of AI machines is going to leverage GPUs or custom silicon that we're developing ourselves, and that's going to require a more dense data center design. We're going to be leveraging higher dense racks. The servers themselves will be liquid cooled to the chip. And with flexibility in mind, we're going to collate servers and network together to enable future generations of AI.
We believe our research supercluster is one of the fastest AI supercomputers in the world. It is one of the unique places where you can run truly large-scale jobs. We have 16,000 GPUs interconnected with 1.6 terabits per second of InfiniBand network, producing approximately 5 exaflops of compute power. We also have almost half an exabyte of storage backing the compute plus network. The advancements in AI are coming at the right time so that RSC can be put to use to take advantage of the infrastructure and the data and then move fast. We design, create, run, and operate all of our infrastructure. So it's a sweet spot of being able to work at scale, work at cutting edge, and also do work that literally hits billions.
Infrastructure at scale is what our long-term research requires, and innovation without it is impossible.
I feel like I'm in the middle of a revolution.
What if all of the world's biggest problems, from climate change to curing diseases to disposal of plastic waste, what if they all had the same solution? A solution so tiny it would be invisible. I'm inclined to believe this is possible thanks to a recent breakthrough that solved one of the biggest problems of the last century: how to determine the structure of a protein.
It's been described to me as equivalent to Fermat's last theorem, but for biology.
Over 6 decades, tens of thousands of biologists painstakingly worked out the structure of 150,000 proteins. Then, in just a few years, a team of around 15 determined the structure of 200 million. That's basically every protein known to exist in nature. So how did they do it? And why does this have the potential to solve problems way outside the realm of biology? A protein starts simply as a string of amino acids. Each amino acid has a carbon atom at the center, then on one side is an amine group, and on the other side is a carboxyl group. And the last thing it's bonded to could be one of 20 different side chains, and which one determines which of the 20 different amino acids this molecule is. The amine group from one amino acid can react with the carboxyl group of another to form a peptide bond. So a series of amino acids can bond to form a string, and pushing and pulling between countless molecules, electrostatic forces, hydrogen bonds, solvent interactions can cause this string to coil up and fold onto itself. This ultimately determines the 3D structure of the protein. And this shape is the thing that really matters about the protein. It's built for a specific purpose, like how hemoglobin has the perfect binding site to carry around oxygen in your blood.
These are machines. They need to be in their correct orientation in order to work together to move, for example, the proteins in your muscles. They change their shape a little bit in order to pull and contract.
But it would take people a long time to get the structure of just one protein.
Absolutely. So what should proteins look like was only started to answer really with experimental techniques.
The first way protein structure was determined was by creating a crystal out of that protein. This was then exposed to X-rays to get a diffraction pattern. And then scientists would work backwards to try to figure out what shape of molecules would create such a pattern. It took British biochemist John Kendrew 12 years to get the first protein structure. His target was an oxygen-storing protein called myoglobin, an important protein in our hearts. He first tried a horse heart, but this produced rather small crystals because it didn't have enough myoglobin. He knew diving mammals would have lots of myoglobin in their muscles since they're the best at conserving oxygen, so he obtained a huge chunk of whale meat from Peru. This finally gave Kendrew large enough crystals to create an X-ray diffraction image.
And when it came out, it looked really weird. People expected something kind of logical, mathematical, understandable, and it almost looked, I wouldn't say ugly, but intricate and complex, and kind of like if you see a rocket motor, right, and all the parts hanging off.
This structure, which has been called Turd of the Century, won Kendrew the 1962 Nobel Prize in Chemistry. Over the next 2 decades, only around 100 more structures were resolved. Even today, protein crystallization remains a big challenge.
Frankly, it is not uncommon that just a couple protein structures can be someone's entire PhD. Sometimes just one, sometimes even just progress toward one.
And it's expensive. X-ray crystallography can cost tens of thousands of dollars per protein. So scientists sought another way to work out protein structure. It only costs around $100 to find a protein sequence of amino acids. So if you could use this to figure out how the protein would fold, that would save a lot of time, effort, and money. What AI has done for proteins is just a hint of what it can do in other fields and on larger scales. In materials science, for example, DeepMind's GNOME program has found 2.2 million new crystals, including over 400,000 stable materials that could power future technologies, from superconductors to batteries. AI is creating transformative leaps in science by helping to solve some of the fundamental problems that have blocked human progress.
If you think of the whole tree of knowledge, there are certain problems where, if they're root node problems, if you unlock them, if you discover a solution to them, it would unlock a whole new branch or avenue of discovery.
And with this, AI is pushing forward the boundaries of human knowledge at a rate never seen before.
Speed-ups of 2x are nice. They're great. We love them. Speed-ups of 100,000 times change what you do. You do fundamentally different stuff. And you start to rebuild your science around the things that got easy.
And that's what I'm excited about. These discoveries represent real step function changes in science. Even if AI doesn't advance beyond where it is today, we will be reaping the benefits of these breakthroughs for decades. And assuming AI does continue to develop, well, it will open up opportunities that were previously thought impossible, whether that's curing all diseases, creating novel materials, or restoring the environment to a pristine state. This sounds like an amazing future, as long as the AI doesn't take over and destroy us all first.
Before the show, we asked you to respond to a question, which we will now reveal the answer to. So the question was, should I, Sarah Hansen, use ChatGPT right now to plan my retirement? What's our answer? Not yet. Okay. Please explain.
Not yet, because large language models are not yet ready to be able to do delegated financial decision making for us. Turns out that saving for retirement is one set of activities, but then spending while in retirement, that's a whole different set of activities. And many of us have become good at saving, but we've been such good savers that we forget that at some point we need to spend. and we have to spend at the right rate for the right things at the right times. So what my colleagues and I are trying to understand now is not only what those optimal decisions are. I think we now have a lot of information about that. There's been a lot of research done on that. But the more challenging issue is how do we communicate that to people who don't have any finance background and moreover can't afford to hire the financial advisors that some of the higher net worth individuals have access to. So we're working on an AI solution, an AI financial advisor that can satisfy the most important criterion of financial advice that regulators impose, which is something called fiduciary duty. A fiduciary is somebody who is appointed to help you further your goals, will look out for your best interests above and beyond their own. And so very often people get a little bit concerned about financial planners and other people in the financial industry because they don't want to be taken advantage of. And, there are many good financial planners out there, but not everybody can afford one. So the question is, can you, for those people who can't afford financial planning and for the financial institutions that don't want to spend their resources of financial advice to those who aren't going to generate enough commissions for them, for these people, can we come up with financial advice from an AI platform that satisfies the definition of a fiduciary, some program that you can trust to look out for your best interest? We're not there yet. However, I believe that everybody should use large language models to help them think through retirement issues more seriously. For example, ask ChatGPT, what are the biggest issues that I need to focus on for my retirement? How much time do I have? What kind of ideas and products and services should I make use of? How do I get better financial information? How do I learn more about these problems? All of those things, I think ChatGPT can do a pretty good job at, but I wouldn't let it make your decisions for you.
Real question for you. I know a lot of times when I put in a prompt that's within my domain of expertise, some of it will be good, but some of it's kind of garbage and not all that accurate. So as a person who doesn't know finance, how do I know I can trust the answers that are coming back, even about those general type of questions?
Well, so that's really why you need to have additional time and effort employed in thinking through these issues, not just by yourself, but with friends and family. So we need human support for thinking about how large language models can work either well or in some cases not so well. And in any case, if you are planning for your retirement, at some point or another, you're going to have to engage with people from the financial institutions. They will be able to help deal with some of the so-called hallucination problems with these large language models. But the answer is like anything else that we do. How do you know that your doctor is always giving you the best information? Doctors are very highly trained, but they do make mistakes. So get a second opinion, get a third opinion, talk to your family members. Ultimately, you're going to be responsible for your own decisions. But the more informed you can be and the more you can check the accuracy of the information, and that information can come from humans or from chatbots, I think those are the ways that we've developed for making sure that we make the best decisions possible to get a better handle on this.
Right. And
the work of having human values be reflected in AI is not strictly a technical challenge with a technical solution, but one that is indeed socio-technical. And with any socio-technical challenge, it has to be approached holistically, meaning you need to be thinking about people, process, tools. People meaning what is the right organizational culture that is required to curate AI responsibly, which are the right AI governance processes, and the right tools and AI engineering frameworks. When I take the time to ask large audiences at AI summits who in their organization is accountable for responsible outcomes from artificial intelligence, the top 3 answers that I get are pretty bad. The first answer I typically get is no one, which is overtly terrible. The second common response that I get is we don't use AI. Although you might not be keeping track of it in a formal inventory program, absolutely you have employees that are using artificial intelligence in some way, shape, or form. And then the last common response that I get is everyone. And I would opine that if everyone is being held accountable for responsible outcomes from AI, is anyone actually being held accountable? The job of those who are being held accountable for responsible outcomes from artificial intelligence is expanding. It's a big job, right? Not only do these people have to actually achieve value alignment within their organizations, they also have to keep track of AI model inventory. They have to keep track of regulations, right? And there are a growing amount of regulations around the world. But there's also a recognition that you can have AI models be lawful but awful, which means their purview, their responsibility actually has to push into ethics. And as soon as you push into ethics, you have to be a pretty darn good teacher. You have to be teaching those not only who are building AI models on your behalf and governing AI models on your behalf, but also who are going to be procuring AI models on your behalf. You want them to be able to do this work, and again, in a way that reflects your organization's values. First, I want to talk about what does AI literacy look like for those who are going to be governing AI models on your behalf. And the best way, my favorite way of approaching this kind of training is applied training. So the way that we work with those who are going to be governing AI models is, first of all, to dive into teaching people how do you operationalize principles like fairness, like explainability, like transparency. Thinking through how do you make sure you can detail what are those functional requirements for what you expect to see in AI models, but also the non-functional requirements of what you expect to see in those systems around the use of those AI models. Then the second group that you would offer this applied training to are those who will be building and buying models on your behalf. And this applied training includes things like making sure that you're choosing AI model use cases to actually work on, which ones are really important to your organization. And then diving into each of those use cases, starting with how do you make sure that the investment in that AI model is actually aligned to your business strategy? Teaching those teams working on those use cases, how do you assess for the risk of that particular use case, unintended effects of that use case? How would you approach mitigating those kinds of risks holistically? Then we give an introduction to fact sheets, in particular, not just how do you build a fact sheet, but how do you build one that's actually interpretable, that empowers people. We give an introduction to audits, and then we teach those teams how do you actually interpret the results from an audit so that they would know what to do when they see those audit results. Those doing this kind of applied training that I'm describing truly, truly benefit from actually working with a diverse and multidisciplinary team. Now, more than ever, having a leader or team that ensures the responsible use and responsible outcomes from artificial intelligence is absolutely crucial. Without a dedicated leader with a funded mandate to do this work, AI governance can absolutely fall through the cracks, leaving organizations vulnerable to the risks associated with the technology. A successful, responsible AI leader has a seat at the table and ensures that there are seats at the table for others, including the CISO, ensuring that AI ethics is weaved into the very fabric of the organization, not just left off at the end, but incorporated across the entire AI life cycle. They make accountability policies transparent and work across the organization to see them implemented. Finally, championing AI literacy in a holistic way is absolutely essential, ensuring that everyone within the organization understands how to build and buy AI models that actually reflects the organization's values. By investing in a responsible AI leader with that funded mandate to do the work, organizations unlock the full potential of artificial intelligence. They drive innovation and they create a culture of responsible and transparent AI use, ultimately leading to better decision-making, improved customer experiences, and sustained business success.
to enact one policy that you think would help AI at this stage, but not stifle innovation, what would that be?
I would say that AI has to be labeled so that if you pick up your phone and you hear a voice on the other end, you don't know whether that's a person or a machine. So AI should identify itself. When you get an email or a text message on the internet, who knows who's at the other end? Again, AI should self-identify.
We believe, as an industry, that in the next 1 year, the vast majority of programmers will be replaced by AI programmers. We also believe that within 1 year, you will have graduate-level mathematicians that are at the tippy-top of graduate math programs. So that's 1 year, okay? What happens in 2 years? Well, I've just told you about reasoning, and I've told you about programming, and I've told you about math. Programming plus math are the basis of sort of our whole digital world. So the evidence and the claims from the research groups in OpenAI and Anthropic and so forth is that they're now somewhere around 10 or 20% of the code that they're developing in their research programs is being generated by the computer. That's called recursive self-improvement is the technical term. So what happens when this thing starts to scale? Well, a lot. One way to say this is that within 3 to 5 years, we'll have what is called general intelligence, AGI, which can be defined as a system that is as smart as the smartest mathematician, physicist, artist, writer, thinker, politician. I call this, by the way, the San Francisco consensus, because everyone who believes this is in San Francisco. It may be the water. What happens when every single one of us has the equivalent of the smartest human on every problem in our pocket? But the reason I want to make the point here is that in the next year or two, this foundation is being locked in, and we're not going to stop it. It gets much more interesting after that. Because remember, the computers are now doing self-improvement. They're learning how to plan, and they don't have to listen to us anymore. We call that superintelligence, or ASI, artificial superintelligence. And this is the theory that there will be computers that are smarter than the sum of humans. The San Francisco consensus is this occurs within 6 years, just based on scaling. This path is not understood in our society. There's no language for what happens with the arrival of this. That's why it's underhyped. People do not understand what happens when you have intelligence at this level, which is largely free.
A typical large language model is trained with something on the order of 20 trillion tokens, right? Or 20,000 billion tokens. A token is like a word, more or less. A token typically is represented on 3 bytes. So 20 or 30 trillion tokens, each on 3 bytes. That's about 10 to the 14 bytes, a 1 with 14 zeros behind it. This is the totality of all the text available publicly on the internet. It would take any of us several 100,000 years to read through that material. Okay, so it's an enormous amount of information. But then you compare this with the amount of information that gets to our brain through the visual system in the first 4 years of life, and it's about the same amount. In 4 years, a young child has been awake a total of about 16,000 hours. The amount of information getting to the brain through the optic nerve is about 2 megabytes per second. Do the calculation, and that's about 10 to the 14 bytes. It's about the same. In 4 years, a young child has seen as much information or data as the biggest LLMs. And what that tells you is that we're never going to get to human-level AI by just training on text. We're going to have to get systems to understand the real world, and that understanding the real world is really hard.
The question is, are we going to be able to develop it safely? And there seems to be not much political will to do that. People are willing to talk about things like discrimination and bias, which are things they understand. But most people still haven't understood that these things really do understand what they're saying. We're producing these alien intelligences. For now, we're in control, but we're making them into agents so they get to do things in the world. And they're very soon going to realize that a good thing to do to achieve your goals is to get more control. And so I'm very worried that We're in a situation now where we'd like really strong, sensible governments with intelligent, thoughtful people running them. And that's not what we've got.